Hi everyone, my name is Subhrajyoti Sen and I'm an Android engineer at Keep Trucking. And today I'll be talking to you about building a better code base with Lint. I'll be talking about what exactly Lint is, how do developers come across Lint on the day-to-day workflows, why you should care about writing custom Lint rules, and how you can write custom Lint rules of your own. So the first thing that might come to your mind is, what is Lint? Lint is a static analysis tool. A static analysis tool analyzes your code base actually compiling it. And since it's not compiling it, it is quite fast. And it looks for common anti-patterns. It can look for performance issues or any kind of warnings. Lint is completely open source and is developed as a part of the Android open source project. All the Lint rules that you get out of the box with Android SDK, those are open source too. And there are about 130 or more Lint rules at the moment that's part of the repository. It works on a variety of file types, be it a Java file, Kotlin, Gradle, ProGuard, XML file. So most likely whatever file you're trying to write a Lint rule for, you're covered. And Lint can be used outside Android as well. So for example, if you're working on a pure Kotlin project, you can use Lint there as well. And it's also very extensible. The API to write Lint rules pertaining to your use cases. So you're not just dependent on whatever Android gives you directly, you can write your own Lint rules as well. And another good thing is it can be done from both Android Studio as well as the CLI. So if you want certain Lint rules to show up while the developer is writing the code, it can show up on Android Studio. I'll be showing a few examples of that as well. And since it can be run from the CLI as a Gradle task, you can make it a part of your CI pipeline. And that lets you run Lint whenever someone makes a pull request or something gets merged to master to make sure that things are in place. So what exactly does Lint look like? Most of us would have come across Lint in a day-to-day use cases and might not have realized that that's what is called Lint. And some of the examples are very common, some maybe not so. The first category of Lint rules would be internationalization. So I think this is the most common example of Lint that developers see. Whenever you're creating a text view, you hard-coded text, and the IDE just tells you that you're not supposed to do that. It recommends using a string resource so that you can translate the strings. The second category would be security. So if you've used web views in your Android apps, you would have noticed this, that whenever you enable JavaScript on the settings, you're warned about potential vulnerabilities and that you should review them carefully. Take a good look at this Lint rule. We would be taking a different look at this particular Lint rule again and explaining one of the important concepts. The next category could be performance. So here I have this custom view called wave view, and let's assume it draws sine waves inside a view. You can see inside onDraw, I'm allocating the paint object, and I get a Lint warning saying that I should be avoiding object allocations inside the draw and layout operations. Now, this is actually hinting towards a performance issue because onDraw and other layout functions can be called very rapidly, and allocating memory objects inside it can be expensive and lead to a performance drop. Rather, you should be creating a global variable here and allocating it only once, for example, on init. And the last category would be accessibility. Again, I'm taking the web view custom view as an example. Here, I have overridden onTouch event, but Lint tells me that I should be overriding perform click as well to play good with accessibility. Now, if you take the Lint tooltip, you will notice this part which says suppress, and it adds the suppress Lint annotation with a certain parameter. This parameter is the ID of the particular lint rule, and we'll be seeing how to define the ID later on. Now that you know what lint looks like, why should you be considering lint, or rather writing lint rules of your own? Android gives you 130 lint rules or more, so that's a pretty big number. But why should you still consider writing your own rules? The first would be having an opinionated code base. Now, as developers, when we start working in a team and the team grows, we tend to form certain opinions that we want to follow in the code base. It could be anything. It could be opening an angular bracket on the same line, or the next line could be tabs versus spaces, or could be anything. Anything that you feel should be done in a particular way in the app, you can make it a lint rule, and that's kind of automating your opinion. And who doesn't like automation? The next would be simpler code reviews. Now, if there are certain patterns that you want to avoid in your code, or certain common mistakes that developers tend to do on your particular code base, you can make them as a part of your lint rule. And if you make them a part of your CI pipeline or a Git pre-commit hook, the developers will get to know about the lint errors as and when they're committing the code. Now, once they fix the code and make the pull request or merge request, the person reviewing it doesn't need to go through the pull request looking for the common mistakes or the common omissions. And hence, the code review experience becomes much better and a more enjoyable experience. And the third advantage would be adherence to a style guide. Now, this is one of the reasons why I started looking into custom lint rules. So most common or most popular apps have certain brand guidelines, which are defined by a design system. What should the font be? What should be, like for example, the letter spacing for different kinds of headers, font size, shapes of maybe, for example, widgets could be a bottom sheet shape, could be a lot of things. If they become part of a lint rule, it serves you two benefits. One, that developers who are new to your project don't always need to keep in mind all the design guidelines. There can be cases where they forget about it or they miss it because they're new and it's going to take time. The lint rule will tell them that you could use this alternate style component that we have. For example, in our app, we were not using the snack bar from material components. Rather, we had a custom class called Tickertape snack bar. And whenever someone used snack bar in their particular commit, Lint would tell them that in this project, we try to use Tickertape snack bar, so please use that instead. And this needn't be true of just new developers. Even developers who have been on the team for some more time, sometimes they might be working on a nasty bug and all their attention is towards fixing the logic or fixing the bug. Then they might, the style guide part might slip their mind. In that case, the lint is a good reminder. Now that you have seen enough about lint, let's try setting up lint. The first thing you need to do is create a new module. In my case, I have named it as lint. You could name it anything, could be custom lint, lint rules, anything that's descriptive to you. Once you have created this module, you have to add these dependencies inside the build.gradle of your lint module. Here I'm using the Kotlin standard library, since I'll be using, I could be using some Kotlin functionality in my lint rules, and they would be written in Kotlin and not Java. If you were using Java, you wouldn't need to include this and you can skip that. The other two, the lint API and lint checks, are part of the SDK provided to you for writing lint rules and running them. Now, before you start writing your lint rule, you need to create some kind of an index, which has a reference to all the lint rules that you write. And this index for lint is called a registry. So here I'm creating a class named registry and extending it from issue registry. For one particular module, you just need to have one issue registry and that's enough. The main thing to focus here on is the member variable issues, which is being overridden here. You can see the return type is a list of issue. At the moment, it returns an empty list since we haven't declared or defined any particular lint rule. Once we do that, we will revisit this and see what needs to be done. Now, once you have created this registry, you need to declare this as a registry so that the manifest can link to it. So inside the same builder gradle, you apply this manifest attribute, and for the link registry v2 attribute, you give the value as the fully qualified class name of the registry. And this is the basic setup needed for your lint module. Now you have to go to your app module or whichever module you want to use the lint rules in and add this block. Normally you add dependencies with implementation, but in case of lint rules, you add the lint check command and then mention your module as a source. Now, before you write any more code pertaining to the lint rule, there are some basic elements you should know about. The first would be scope. Scope is the kind of files that the lint rule applies to. Like I mentioned earlier, a lint rule can be written for a variety of file types. This is what you can see here. There's a Java file scope, Gradle, manifest scope, ProGuard, and the resource file scope. Now, the resource file scope might not seem that specific as the others because it specifies particular file types. The resource file scope is it's a bit broader scope, and we'll see later on how we can narrow down that scope. And you might wonder why there is no Kotlin file scope. That's because whatever lint rules you write for Java file scope, they're applicable to Kotlin file scope as well. And this is possible because the lint rules don't directly apply on the structure of Java files. Rather, they work on something called an abstract syntax tree. And you can consider that as a superclass of both Java and Kotlin. So whatever you write on Java file scope will work on Kotlin file scope with a few considerations. Next would be the severity of the particular lint issue. You can see that there are 4: informational, warning, error, and fatal. Informational is when you just want to guide the user and guide the developer in certain direction. Warning is something that should be avoided, but it's okay even if it's not. Error is something that you want the build process to, you want lint to completely fail whenever that particular issue occurs. And the last one is fatal. Fatal is for those kind of issues that should never be merged or should never be technically pushed to production. If lint comes across a fatal issue, it will break your build and it will enforce that you cannot make your build so that you fix it, because you define something as fatal and it's to indicate that this has to be fixed before you make a new build and push it anywhere. And lastly would be the category. You can see the categories here are security, performance, localization, and accessibility. Okay, I think there's a typo, it's internationalization and accessibility. And we saw the examples of these in the first, we saw each example for these categories in the initial lint rules that we took a look at. Now, coming to a first use case. This is again a design system or a style guide. This is specifically a style guide. Now, we have the style guide where we mention different kinds of styles, for example, H1, H2, H3 to specify different kinds of headers. And you can have many other different types as well. And each has their own property. But our use case was that we wanted to specify a style for every text view that we had. And in case a developer missed it, we wanted a way to inform them so that it didn't really have to go to the pull request phase for the to and fro to happen. They would be informed that they missed out a style in one place and that they should be applying a style there. So now we'll take a look at how exactly we constructed that lint rule. So let's look at the metadata of a particular lint rule. So for the rule, you have to create an issue. If you remember the registry that we created, it returned the method in the registry returned a list of issues. And this is the same issue that we're instantiating here. We use the static create method to create an issue instance. And let's take a look at all the attributes one by one. The first attribute is the missing style attribute. This is the identifier of the issue. And if you, for example, want to disable this particular lint rule at some point, this is the ID you would use. Or for example, if you wanted to suppress this lint in a method. So in the initial examples, when you saw that the lint tooltip was suggesting that you could suppress this lint rule and the annotation took a certain parameter, this is that parameter. The second parameter is a short description of the lint rule, just a quick glance to the developer of what's going on here. And if the developer wants to know more, there's a bit longer description as well. So if you want to give reference to a certain page that they should look at, or some part of your internal documentation that they should be looking at, or any extra info that you want to give. The third parameter would be the category. Now, this particular lint rule did not fit in the categories that we defined earlier. So here we're using the correctness category. The next, the number 5 here is a priority level. You can skip the priority level for now. The next would be the severity. Here we have defined it as error because we wanted lint to fail anytime style attribute was missed in a text view. And the last attribute and the last parameter is an implementation instance. The implementation instance has two parameters. The first would be a reference to the class that defines the lint rule. If you see in the issue, there is nothing that defines the rule. It just tells certain metadata. Missing style attribute detector is where the core logic of the lint rule will reside. And the other parameter is the scope. Here I'm using resource file scope. Now, if you think about it a bit more, the resource file scope would apply to all the files inside the resources directory. You could have fonts, you could have the values, and inside values, you have a lot of different XMLs. So this would be going through a lot of different files to check for your particular lint rule. Now, this won't be that efficient. So we will see how we can narrow down the scope a bit more later on. So this is all you need to create an issue. And this is the issue that will be written by your registry. Now coming to the custom rules structure. Here, as I mentioned in the previous slide, missing style attribute detector is where the detection logic will lie. So here I've declared the class and I'm extending from resource XML detector. There are different detectors depending on the file type you want to work on. And detectors are needed because each file type will have its own characteristics. If you're looking at an XML file, you would be worried about the XML tags that you're using. What are the attributes being used? What are the values for those attributes? But if you look at a Java file, you're not worried about any of that. You're worried about the kind of variables being used, what are the methods being called, what are the parameters to the methods, such things. And that's why we need all these different kinds of detectors. Here we're using resource XML detector because we wanted to apply on XML files inside the resources directory. The first method that you need to override is get applicable elements. It returns a collection of strings, and this is where you define all the elements or the XML tags where your lint rule will be applicable. In this case, I'm returning a list with just one word, that is text view. You might notice there's an instant code smell here, and is that I am hard coding the string here and passing it. Technically, you should be avoiding this whenever you're writing a lint rule. Rather, you should be using something like this, SDK constants.txt view. And constants is a file that comes along with the lint SDK. And it has a huge collection of constants that you can use. And the reason I'm emphasizing on this is because I personally made a typo when I hard coded the text view. And I spent a really long time trying to figure out why my lint rules were not applying. The next method that you need to override is the applies to. And as a parameter, it gets a folder type. Now, remember when I said that our scope was pretty large and it would go on all the resource files? Here we're narrowing it down more. We are saying that this will apply to an XML file inside resources only if the folder type is layout. We have narrowed down our scope quite a lot. And the last bit would be the visit element. This is the method that gets called whenever the conditions for your lint rule or the scope that you have specified is actually visited by the parser, and you would get the parameters as a context and an element. Now, using the element, you can check the various properties of the element. So in our case, we wanted to know if the text view had the style attribute. So this is what we're doing here. We're checking if the element has the attribute style. Again, we're using an SDK constant here, and you should as well. Now, if it does not contain that particular attribute, we want to report it. Now, the report needs to be contextual. There should be a way of telling the developer that the error or the particular warning happened at this file and this column number, this row number, so that they can pinpoint it really easily. And this is where context comes in. Now you'll notice that the first parameter is the issue instance that you created. This is how it all links up. The second would be the element. And the third would be the location from the context. This gives you the file name or the line number and column number. And lastly, a short message to tell what went wrong. Now, let's come back to the override method get applicable element name. Now, this is particularly very important because it tells your lint rule what exactly should it be applied on. If it didn't do this, lint would go through every tag that you have mentioned in all of your layout directories, and it would start applying this rule to it. Now, remember the JavaScript lint rule that I talked about? Let's take a look at a small bug related to that. Here I have a test class that has a method called set JavaScript enabled, and it takes a Boolean flag. Now, if I create an instance of this class and call it set JavaScript enabled, Lint fires up and tells me that this can introduce vulnerabilities. But technically, that's not true. My JavaScript enable function could be doing anything and not what the WebView implementation does. Now, this case might not occur for you. It might be a very rare case. But it's always good to know that such things can come up if you are not very specific about which particular elements or files your lint rule should be applied to. Now that you have seen everything about lint, how exactly do you go about integrating it? Hopefully I've convinced you at this point to start taking a look at writing your own lint rules and also caring about lint. So once you think about, once you make the decision that you want to do lint better on your app, or first fix the issues that already exist, or the issues that come up after you write your lint rules, there are two that you can take. One would be incremental fixes. So as a part of every sprint or every release cycle, you can fix a bunch of lint issues and ship them. And the second approach, which is, I would say, recommended for bigger apps, is using a baseline. So whenever you use a baseline, Lint will create a snapshot of all the errors that exist in your project at that moment. And on subsequent executions, it won't show these as errors. Whatever new comes up will be the one that are actually shown by Lint. So if you have a project that has, for example, 150 Lint violations, it wouldn't really be possible for you to just go at 150 together. So what you could do is put them on the baseline, and then whatever new ones come into your code base, start fixing them. And at some point, you keep clearing the backlog. So let's see how you declare a baseline. So inside your app module, you would be declaring the lint options block. And there you will be specifying the baseline file to be used. In this case, I'm using lint baseline.xml. You could use any file name. And if it doesn't exist, Lint will create one for you. And if it exists, it will override that. Now, let's see how baseline works. I have this certain project, which is available on GitHub. I run Lint debug on it, and you can see that it fails. It writes an HTML and XML report. And right below that, you can see it created a baseline file at the given file. Now, this has written the current exceptions to the baseline file. In my case, there was one error, and that got written to the baseline. Now, if I run Lint debug again, here Lint debug is a Gradle task. Now here, if I run Lint debug again, you can see that it passes successfully, but it also mentions that one error was filtered out by the baseline. So you can see it won't break your Lint, as in you can continue your workflow. But at some point, you should be taking a look at this baseline file. Unless it's some Lint rule that it's completely okay to avoid, then it's completely fine. Now, if you open up the Lint baseline file, you can see that it's pretty close to how we had initially declared an issue, that we have an issue ID, the message, the error line where exactly the Lint issue occurs. So it creates a small snapshot to tell you where exactly in your file the error occurred, and it says that it's at the starting of the text view. And there's this location tag that specifies the file name, the line number, and the column number. So remember how we had a context reference? The context reference gives us access to these values. Now, the next concern would be performance. Would including Lint degrade the performance of your builds? Let's take a look. So Lint occurs in two ways, or Lint works in two ways: single pass and multi-pass. Single pass, an example of it would be a missing attribute. In the first pass itself, it can see if you have certain elements and if those elements are missing the attributes. One pass, pretty performant. And these kind of Lint rules can be enabled in your IDE. For example, the missing style attribute, you'd get to know in your IDE itself that you have to specify this attribute. And the next one would be a multi-pass. Now, in a multi-pass, Lint would have to do multiple passes of your code base given in the scope. And it might be twice or it might be multiple times depending on what kind of you're writing. Let's take the example of unused resources. You would have noticed that unused resources Lint rule doesn't always get triggered. It's only when you manually enable it while, for example, pushing your code base or doing some other kind of optimization. This is where it kicks in. This is because unused resources needs multiple passes. In the first pass, it needs to know what are the resources available in your app. In the second pass, it would go through the different files, searching for the usages of these, and that's how it can figure out if certain resources are being used or not. And since this is an iterative approach, it can be slow, and hence it's disabled in the IDE. If you consider enabling this in IDE, given that with every time you write code, this would be run and can be slow, you would get a very laggy performance. You can go into the Lint options inside Android and see all the Lint rules that are enabled by default. You will also notice that there is a bunch of Lint rules which exists but are not enabled. And lastly, Kotlin considerations to be made while writing your Lint rules. Like I mentioned, the Lint rules that you write for your Java files will also work in Kotlin files with some considerations. So let's see what those considerations are. Kotlin might not have explicit return statements. You can have functions which don't even write the keyword return. Similarly, you don't need to specify explicit return types. It could be implied from whatever value your function returns. Now, if your Lint rule was specifically looking for the return keyword, this might be an issue because in the Kotlin file, it might not find it. Similarly, type declarations. In Kotlin, you can have something like val a equal to 10 without specifying the type explicitly. if your lint rule was looking for those specific type specifiers, it would fail. So the way you can tackle it would be to write a test case for your Kotlin usage. So if you have a function that's written in Java, what you can do is see how that function would be used in Kotlin and write it normally how you would. So in a normal practice, if you wouldn't mention the return type of a function, that's fine. Write it similarly and see if your if your lint rules pass on that Kotlin file. If it doesn't, you know what are the considerations you'll have to make for your usage. If they pass, it's great. Uh, Here are a few references to where you can learn more about Lint. The first is a Google group named Lint Dev, where many people discuss the kind of Lint rules that they want to write. And there are pretty good discussions happening there. So if you want to engage with people writing Lint rules, look at it. And it's a quite good resource to know about things people are working on. The second would be the GitHub link for the project accompanying this talk. It has a couple of other lint rules as well as how to write a test case for a lint rule. So the example that I showed here, the missing attribute, it contains tests for that particular lint rule as well. The third is a lint rules repository, and this is a huge collection of lint rules that vary across a lot of use cases. It could be using Vue, could be using RxJava, and multiple others. So it's a great resource to learn different kind of lint rules and what the API is available to you. And lastly, there's a talk by the folks at JetBrains, and it's a bit deeper dive into the Kotlin Lint API and what are the things you can achieve with it. And that's all, folks. If you have any questions about Lint, or if you want to discuss the kind of Lint rules you want to write, or if you have any feedback for the talk, you can reach out to me on Twitter at my Twitter ID. Okay, the first question is, a certain demerits of Lint. How did you go about it? While writing the Lint rules for our use cases, I didn't come across any, I would say, demerits. The initial concern was about the performance. And build time. Our build times weren't that affected. Do you use baseline files for your feature library modules? I found it difficult to manage them. Since we're on a relatively newer project, we started using Lint early on, and our developers took care to, I would say, tackle Lint issues early on. So we had very small baseline files, minimal usage. Is there a way to write Lint rules to Kotlin files only? You can, yes, you can. If you don't want to make the Java considerations, you can just directly work on the AST and write it for them. It's if you write for Kotlin, you won't really have to do much of a consideration for Java. Can you explain what a lint is? Okay, a lint a lint is not specific to Android in that case. You have a lot of different lints that work in different languages. It's just a way of statically checking if there are any issues in your code base. Any idea why I might be getting false positive for unused resources? I'm not really sure about that. I haven't come across such a case where there was a false positive. So yes. Okay, is there any negative impact on using custom lint rules on a project? Could it, for example, increase build times? Yes, it can. That depends on the scope of the lint rules and also the kind of logic they implement internally. So yes, there can be one, but if it's written in an optimal manner, for projects, you might increase your build time by maybe 1 minute. At least in our case, it was, I think, 30 seconds. So for bigger projects, I'm guessing 1 minute or 1.5 minutes. Can lint also be used to format code like KT lint? In case of Lint, you can suggest certain fixes. So there's a fixing API that you can use, which works similar to KT-Lint. So given when a certain condition is met, you can ask it to replace certain code. For example, if you have used the Timber library by Jake Wharton, whenever you have it integrated in a project and you use log.d, for example, the Lint rule will tell you to use Timber instead, and it will also give you a fix option. Now, using this option, you can auto format the code. The suggestion of the Lint rule was. It can get a bit complicated for complex use cases, but for most of the use cases, it should be pretty straightforward. Okay, I think that's okay. Do you recommend multiple detectors? Uh, it depends. What we tried doing was categorizing the kind of detectors that we were writing. So if it was related to a certain view type, all of them would be in a single detector and they would come up together. Otherwise, we were writing separate detectors for them. And a very good reference for this would be the AOSP project for lint rules. And you can take a look at how they categorize and use different detectors to write the lint rules. Because like I mentioned, with 130 plus lint rules, you have a lot of examples, some complex use cases as well as simple ones. And they use all kinds of detectors possible. Okay, I think those were all the questions that were there. Thank you so much for coming to my talk. And if you have any feedback or if you want to discuss anything regarding Lint, please do reach out.